My research area is in ICT for development but for low resource environments. And so, and AI falls under ICT as well. And so the same concepts of development for low resource areas in any IT related solution is the same things that correspond to an AI solution as well. But of course, we can appreciate that the complexity of AI may introduce some added complexities when it comes to development, even in places with enough resources. Now, in terms of ICT for development projects, there has been a lot of development over the years, and a lot of these started before the introduction of AI. And there were a lot of these interventions that didn't work because, or didn't work too well. So we remember things like one laptop per child and ICT kiosks that were placed in different places around. I'm sure some of the people from Ghana may remember, things like these where, a very long time ago, where we had people brought all kind of containers with computers and stuff like that. And for some reason, most of these projects never really worked too well. Some of them to some extent, at least one laptop per child worked to some degree. And part of the reason why these interventions don't work very well is it's mainly because there is not an inclusion in the end users. If you don't think about what the end users want, or you don't find out what they need, then the solution you create may end up being something that they do not want to use. And that was one of the major issues. There are other problems we will talk about, but that was one of the problems with all these interventions. Fast forward to recent years, and we have newer projects that are beginning to think of all the mistakes that these older projects did. So, for example, with W4RA, I am sure over the last lectures and talks that you've had, you have heard of some of these things. So we have a number of projects by students and some by the research group and others by myself. And these are projects that we have done with in low resource environments. And so we have gotten a good idea of how to go about these things. And these things are meant for development. So Foro Bablong was an app that was used, an app that was used as more like a social media app for illiterates. Mr. Meteo is an app that gives weather information to people who do not speak English or do not read and write. And then Tibangsam was a project that we did a few years ago that basically gives information to rural areas in their own languages over FM frequencies. I can't go into exactly how it works because that's not the main aim of this talk, but just to show you that all these projects, we began them and they worked because the projects began by thinking of the end users. The project began by considering the needs of the people. For example, Mr. Meteo, this is an idea that came from the community members and didn't actually come from us. And so for that reason, you'd be assured that it will be used because this is something that the people have asked for. So the question we want to ask today is, all these projects we've talked about are meant for development. So before we even begin to talk about AI4D, the question is, can AI really foster development? And immediately we talk about development, we are talking of, we immediately think of our sustainable development goals. If your project or your solution does not tackle one of these development goals, then most likely it does not actually foster development. And so we come to that question: how do we use AI, especially when we are talking of low resource environments, places with no proper internet access, places with not proper electricity. And then also when we talk of low resource environments, you realize that there are certain SDGs that we immediately focus on and others that we kind of leave for later, because these are places where we have to even start tackling the idea of zero hunger. We are talking of places that don't have enough food yet, or don't have enough health yet. And we are not yet even talking about things like sustainable cities or smart cities or things like that, because these are very low resource areas and we need to build them up gradually. So the question is, and I just put some examples of course, the answer is that yes, AI can foster development. You have heard this already for a while now over the number of lectures that you've had. So examples are, for example, agriculture. And some of you have already selected use cases that are geared towards this. So for example, agriculture, we can use AI to improve quality and accuracy of growth of plants, to detecting diseases in plants, using sensors to target weeds and detect weeds so that you know where to apply herbicides. And these are things that can actually help actual development, especially in places where we're talking of low resource environments. Most low resource environments, especially in Africa, tend to be the places where agriculture is done more, because that is one of the most straightforward and simplest job to do, to immediately solve the problem of hunger. And so because of that, agriculture is prevalent. Health, we have a use case on health, and an example of health is natural language processing can be used to read health information and then kind of analyze and unstructure the whole structured clinical information. Then gender is one issue also in low resource areas, because we realize from our research and most research that there's always a gender disparity. As well, as much as this solution, this expert system is not really for low resource environments per se, but an example of how AI can help gender. So we actually have AI expert systems that kind of screen and hire people for jobs as opposed to using a human being, because we know human beings can be biased when it comes to gender. Both male and female can be biased when it comes to gender. And also use expert systems to avoid gender-coded words. There are certain words that immediately ring gender, and use AI to also process CVs so that you can redact or remove any information that shows the gender of the person. In that way, when you're looking at the person's CV, you have no idea what gender the person is. You're focused on what job the person can do. So this is an example that is a bit out of our scope, but at least it gives an idea of what we can do about gender. Clean water, IoT is Internet of Things. IoT is normally using devices and sensors to be able to detect various things or control various things. And IoT is these days used a lot in conjunction with AI. So clean water can actually is something that we can tackle using deep learning neural networks to detect bacteria in water, where we have sensors or devices that can read at a microscopic level and give us real-time detection of when, for example, you set up a borehole in a rural area and you keep monitoring the water that comes out of it. In case at some point there is any bacteria or harmful particles in it, and then we can know that there is something wrong with this particular borehole or pump that we did somewhere else. Clean energy, machine learning is being used these days to help the grids, the electricity grids, so that they can better manage the electricity and manage their schedules and for maintenance and all that, so that there's a bit more efficiency in the energy produced. So these are some of the things that can actually foster development. But then we come to those that are dealing with low resource areas, and we are going to realize that there is still a problem. And that is that if we want to, okay, I think I can skip this slide because these are just the use cases that we gave from Ghana. So we already know quite a lot about this. All right, so the problem we have are the barriers. Now, when we come to the kind of places we are talking about, the rural areas in, let's say, in Ghana, northern Ghana, or in Mali, Burkina Faso, these are problems. We have computing capacity. We have connectivity issues, literacy issues. We have contextual issues. We have electricity issues, maintenance, and cost. These are some of the major ones I just want us to go over and understand what the problem is, and then what we can do about it in the solutions that we think about. Now, the first one is computing capacity. An article I just read, the link is in the notes of the slide when you get it. But he says that there are only a handful of supercomputers on the continent, with few ranking on the global stage. And this he's talking about Africa. So there are very few supercomputers in Africa. So the processing power you would need to handle the bigger solutions of AI simply do not exist in Africa. In Ghana, we don't have a supercomputer. We have something that which is approaching a supercomputer, but actually it's not. And even with that, we are kind of probably a bit ahead of most countries. Most of the countries don't have a single supercomputer. And even if they did, that means that everyone needs to use the same supercomputer. And so computing capacity can be an issue. How do we compensate for this? We think about things like remote processing. We probably have to process our data elsewhere and then transfer it back to the system we're using. We think about distributed systems. We may need to distribute our algorithms and process them on multiple processors and then pull them back, or figure out how to use multiple machines to process. There are some interesting projects of recent that are kind of using individual mobile phones to do processing, because the truth is that most of the time we don't use a lot of the processing power of our phones. So for example, right now my phone is lying beside me. For the next 1 hour, I probably won't touch it, and it will only run the background stuff that it needs, but every other thing is closed. So I'm actually not using that much computing capacity on it, and some application I install can probably make use of it and as a distributed system. And then together, if you have thousands of phones running your application, then you may have enough computing power. Lastly, and probably most importantly, we attempt to build non-complex systems. So as much as AI sounds very complicated and it sounds very very complex and huge, when it comes to low resource environments, we have to think of decomplexing the solutions and creating something that is far less complex than the AI we have in our minds. And so sometimes we have to come down to the level of basic AI, things like solid state, finite state machines. These are or search algorithms. All these things are actually AI, but in recent years, because of things like natural language processing and machine language and deep learning, we have kind of left the less complex algorithms and ideas of AI behind. And these were the systems we're using that are used to for AI in games and things like that. And they are a bit less complex than the bigger AI solutions that we are doing these days. So think of something simple. try to move down a little bit and think of the most simplest system that you can come up with, as opposed to something complex. The next issue is connectivity. As you may have noticed already from this course, you would notice that the African participants, we sometimes go off, we sometimes come on, we sometimes speak, and our voice breaks off, our video goes off, and all that. At the moment, I have thankfully Zoom kind of added a feature which I really like, and that is to put off incoming video. And it really helps us here because I actually do that. I'm actually doing that right now. Else, my bandwidth has to actually process all the incoming video as well as my outgoing video. And most of the time, our bandwidth is not good enough to do that. Or even if it is good enough, sometimes it's not stable. It is maybe fast and not stable, or it is stable and not fast. And so connectivity is a big issue, and we have to really think about internet connectivity. We cannot build, although we are thinking about AI systems, we cannot build systems that depend on 100% available internet, because that almost doesn't exist in, for example, in the northern part of Ghana. You would not get 100% connectivity to the internet. So we think of course, we almost don't use 3G and GPRS anymore, but we have to think of different systems that we can use as opposed to using 4G. So existing solutions that we have actually used in the solutions we have done recently are GSM, SMS, and FM. I know that these do not sound like things that can be used to transmit data, but you have to begin thinking. Remember, before you are kind of thinking of a non-complex system. And so if the system is not too complex, then you can actually use a data system that is also less complex. So we have used GSM, for example, in making calls, and the students who were part of the just ended course in ICT4D understand this well. So as opposed to using any other form of transmission of information, we actually use GSM. We can use ETMF for people to input information, and then we transfer it over to our servers and then work on them. With Tibangsam, which is the RadioNet project, I actually used SMS to actually transmit information to and from a Raspberry Pi, and actually also used the SMS to actually run the what's it called, the command line, the commands on the Raspberry Pi from wherever I am, because these Raspberry Pis were set up in rural areas which were hundreds of kilometers away from where I was. But I need to run Linux commands on their terminals. So what do? I set up a server there that receives SMS and then processes it on the terminal, gets the result, and sends it back. So for example, you can see in the picture, I send an LS and it actually does it and gets a list of the files and returns it over SMS. And these are various ways of thinking of how to overcome this barrier of connectivity, instead of focusing only on 4G or 5G, which we don't even have yet. So basically, you have to compensate for the availability and reliability. It's not always that internet does not exist. It would be there, but it would not always be available and not always be reliable. So you have to consider that. The other barrier is literacy. So Ghana has a literacy rate of 70%, which I mean is considerably high enough. Other countries with high literacy rates are Togo, Ivory Coast, Nigeria. Some of these around 80s, 90s, and just about 60. So these rates look fine until you move to a certain part of the same country, and then you suddenly realize that there's a disparity. So in Ghana, for example, if you shift towards the northern part of the country, the now five, I think, regions in the northern part of the country have an average literacy rate of 40.82, which is very different from the national rate. All right, so we realize that when we talk about this digital divide and literacy divide, there's actually even a divide within third world countries where the national rate might be high, but actually there is still an issue somewhere. And there are other countries that are far low. Burkina Faso nationally is 50% literacy. Mali is about 30%, or I'm hoping a bit higher now. This rate is from a few years ago. And so literacy is a problem. It means that the people you will tackle most likely do not speak English, most likely do not write English, and most likely do not read English. And this can be a big problem because it means that you have to start thinking of local languages. Your solution may work in however it works with a programming language or in whatever it does in the background, but by the time you produce information for the user, it has to be something the person can understand. All right. So the solutions to this, you attempt visual presentations, so you can use visuals to show people what you are trying to say, or you attempt to use languages in their own languages using voice technologies. And in relation to that, we come to context. Now, with context, there is a big issue with knowledge representation. You have to be a bit careful because I just mentioned using visual representations, but then you have to be a bit careful that the people understand the representations that you are actually showing them, right? These are two examples. One is an example for both the global north and south worldwide, which is the save symbol. I think I came across a joke where a child made a comment that their father did a 3D print of the save symbol because he saw their father holding something that looked like the save symbol. But actually, that was a floppy drive. That's for those of you who remember what floppy drives are. And it is possible that some of the people I'm speaking to have never actually seen a physical floppy drive. And so the save icon actually doesn't make direct sense to the present generation. Is that called Generation Z or something? I don't remember what they are called. But the younger generation actually don't really know what the sign means. They have grown up to know that the sign means save, but they have no idea that the sign actually came from a physical object. And so that can be an issue when you are representing knowledge with visual representation. Another example is this emoji for the thumbs up. Now, when you use Skype, especially I always remember Skype, this emoji is animated on Skype, and the emoji is something like this. I hope you can see my finger. I can't see my video, so I'm not sure. All right. So now this symbol is in Skype. They just try to do it so that they'll show you the thumb is coming up. But I'm sure as I am doing this, the Ghanaian participants have already realized that this motion is an insult in most places in Ghana, and probably even outside of Ghana as well. And so if you don't understand this concept, you may end up putting representations that do not mean what you think it means, or is totally means something else, and you are insulting the people. And so it's a bit important to understand context, and it's a bit important to involve the users at an earlier stage, because once you involve them at the beginning and they see the symbol, they'll be like, don't dare put that there, and then you would know that this would have been a problem. And then lastly, I think is electricity. That's I think one, but last is electricity. So electricity definitely is an issue. Oh, sorry, I have a bit more than that, so I'll rush through them. So electricity definitely is an issue. I mentioned this already. We have power cuts. Power cuts here are normal. It is bound to happen. And so if you build systems here, you must, for developing countries and especially for rural areas, they must be systems that are able to recover. They must be systems that can easily be put on and put off without having to go through a whole shutdown process, because the power would definitely at a point go off. You can also think of to compensate for the availability of grid power by using alternative power sources, especially solar power, because we have a lot of solar power. Maintenance, of course, is also an issue, especially when you need to deploy hardware in low resource environments like countries like Ghana, especially like the north of Ghana. For example, dust will be a problem. So devices that will have movable parts will probably get dust in them and they'll clog up the systems, which is one of the advantages of plug computers like the Raspberry Pi, because they don't actually have movable parts. Heat is also a problem. The temperatures in northern Ghana, we sometimes reach 40 degrees Celsius, and that's quite hot. That's very hot. There are other countries that also get very, very high degrees, even above this, in other places in the world. And so heat can be an issue. And so you have to consider these in if you are deploying actual hardware. The first thing is attempt to deploy hardware that will take the least amount of maintenance required. Have stakeholder involvement so that the stakeholders, people involved in the things you are trying to implement, can give you an idea of what will work and what will not work, or at least can take over the systems and maintain them, because at least you would have some technical people among those stakeholders. And then, of course, you must build robust systems. The systems must be able to withstand a lot of harshness. Yes, and then lastly, cost. I believe this has been mentioned a number of times. Billions of dollars is being poured into development of AI, but in the systems here, the reason why the West can pour billions of dollars is because the end user is willing and able to pay for the services that will result from these systems. Or the country is rich enough to be able to subsidize on the cost of some of these services that will come out of it. And so it can be afforded. But in most of these low resource environments, we are actually in the process of trying to help the poorest people, meaning that they can't really afford that much. Most of these people are nowhere near $1 per day. I mean, not even close. And so your system, we have to think of affordable systems. We have to think of affordable hardware. We have to think of open source. We cannot afford software that we have to pay for because we can't afford a subscription, or we can't afford the money that will come, and we'll have to go out to get software. So we need to rely on open source. And then you need to build a system that is financially sustainable, which is probably one of the biggest problems or the biggest challenges, because we are at the same time, we are saying that the end users cannot afford, but in the same breath, we are also telling you to build a financially sustainable model. And this is it's not something that can be answered. You would have to sit down and think about it in context of the particular solution and see where can the money come from? How can it move around and still be sustainable? And so these are the various barriers you'll tackle. So what I would say is we have to fight these barriers. So become developers who think of contextual barriers. You immediately you are attempting a solution, begin to think of the context, to begin to figure out the local context. I've had questions today from some of the groups. For example, I think one of the groups asked me about limitations, and that means that they are thinking the right path. You immediately realize that, okay, what we are talking about, there are definitely going to be a lot of limitations. So what are these limitations? And then you figure out how to battle them. Consider that how the context may change when you are scaling your solution upward, because you are creating solutions which we may need to scale upward. And we may need to scale to different languages, different communities, different countries. So consider how the context of what you're doing may change or may not change. Develop with a bottom-up approach, not the up-down approach where you're just developing and throwing it to the people. Develop with coming down up from the end users and from the people who would, at the end of the day, benefit or use these solutions, and think of the things that they need and what they want out of it. And of course, think of cost, as we've mentioned. And then and we talk about these last three. It should be interdisciplinary, because as a programmer, I do not know much about agriculture. I don't know much about horticulture. I don't know that much about health. And if I attempt to develop AI systems for some of these fields, I may end up doing things that are wrong if I do not work with the people. All right. So we should not tell the health people what they want. They should tell us what they want. And then we find out how to develop it. What we can tell them is what is possible and what is not possible. And then they can tell us, okay, we want this and we want that. Same with agric, same with any other field. And then let it be a collaboration. We work together with stakeholders. When I say stakeholders, I'm talking of most of the solutions we are talking about, let's say for farmers in rural areas, we have institutions and we have universities and other companies that already work with these farmers. And so as opposed to bypassing these people, what we rather do is collaborate with them and provide solutions for them, which they can in turn now use for the people. And when you do that, it's a bit more helpful because everybody understands what is going on and everybody can help. And then, of course, lastly, let it be end user centered. It must be centered on the end user. It must be centered on the one who will use it. We know it's an AI system. The end user has no idea what AI is, and we may never be able to even explain what AI is to the end user, but we can explain what it should do and what it should change. And so the end user should know that this is what you're doing and should be able to, and don't discredit their feedback. Yeah, I know in this course, we may not speak to actual end users, but in the future, if you do projects, you do not discredit their feedback may sound very untechnical and maybe sound like nonsense to you, but when you consider it, brainstorm on it, you may realize that there is some indication of some technicality that you can help them with in your solutions. So basically, these are the barriers you will face both in this course with your design and both in the future when you attempt to work for low resource environments. So basically, that's my talk on AI for development. Any thoughts, any questions?
Thank you, Francis, for a very interesting and comprehensive talk about ICT4D and AI4D. And I think you have touched on all the important issues and you have given a lot of background also to these issues and explained why these things are so important. So yeah, many thanks for this excellent talk. So I hope that there will be questions. The floor is open. Yeah, Adrian, please.
Yeah, you mentioned use of distributed systems, but I remember from the prior ICT4D course that use of cloud and stuff is very limited in low resource environments. And what kind of distributed systems would be interesting then? Or does cloud potentially have a future in low resource environments even?
Yes, I think it is possible, but as I mentioned, I'm more of talking of using remote distributed systems as opposed to actually distributed systems on the ground. But the first thing that comes to mind, and this is not really something I have done or researched into, but the first thing that comes to mind, of course, is mobile phones. Africa has a lot of mobile phones. Ghana has like almost 140% penetration. And these days, in most urban areas, almost everyone has a smartphone. And so although we can't use we cannot probably rely on the traditional cloud, but one thought is we can rely on the mobile phones of the very people in the same country. In that way, using the urban people to help the rural people, where probably we are running solutions on their mobile phones. And at least in the urban areas, most of the phones are connected to the internet. Again, the internet is not going to be reliable and available. So again, that brings in more complexity because it means that in a distributed system of that nature, sometimes some part of your algorithm may not be available at the time you want it. Maybe the solution to that would be I've forgotten the technical word, but duplicating, where so maybe you have 100 mobile phones running one algorithm and another 100 run another one, so that if one is unavailable, you get the But these, I mean, this is a new thought that came into my head, and it's not something that actually exists. Yeah, but as you said, cloud, using the cloud for some of these things is still an issue, because we may not really have proper access to the cloud. But having said that, as I keep saying, the internet access is it's available. It's just that it's not reliable. So you can actually build a system that depends on the cloud, but then you must realize that your system will not always have access to the cloud. And so you have to build some redundancy in the system and probably have an online and an offline backup when you're not able to get to. So that's roughly the idea.
All right, thank you.
Okay, so thanks. Are there more questions? Okay, there are no more questions, I see. So then I would thank Francis again, and I think we can move. Oh, there Lucas has a question. Lucas, go ahead.
Yeah, I still have one question to Francis. So what is your personal opinion and thoughts on what the most beneficial kind of systems currently would be for, well, Ghana as a whole, or Northern Ghana specifically?
Oh, well, that's an easy question to answer. The most beneficial systems are exactly the stuff that we actually presented as use cases. So basically health, crop because of agriculture, irrigation also because of agriculture, because we have a very huge long dry season where there is no rain in the north of Ghana. So we actually need irrigation a lot, and so improving irrigation is very necessary. And then of course text to speech for our languages, because that will actually solve a lot of problems with regards to the literacy I mentioned. If we could have had text to speech for our local languages, then a lot of these solutions for providing information to them wouldn't have been a problem at all. So basically, these are the most vital and most needed solutions that AI can provide for especially for Northern Ghana. I can't speak for the other countries, but these are the ones I can think of for Ghana.
Okay, thank you.
Yeah, welcome.